Hello, everybody. Happy Friday. I want to remind you that you have your quiz on chemical bonding on Monday, which is the 3rd of November. So what we're going to do today is we're going to do a real quick, there I am. We're going to do a real quick lesson on bond energy. And then you can have the remainder of your time in the block to work on your quiz review for your quiz on Monday. Sorry, my Chromebook is going to power down, I guess. All right, so I better get to it then because I'm about to run out of battery. Let me go ahead and let's do this quick lesson on bond energy. All right, here we go. This isn't going to take long, just a couple minutes. Okay, so one thing I've been trying to fit in this unit is this lesson. And basically this lesson is about the energy changes that occur when a chemical bond is formed between atoms and when a chemical bond is broken. So before we really get into it, let's just get a couple of key things down. Most unbonded atoms, wrong way, sorry. Most unbonded atoms are less stable than when they're bonded to some other atom. So in nature, stability and energy pretty much have an inverse relationship. The more unstable you are, the higher in energy you are. So once an atom forms a bond, it becomes more stable. Usually it gets its 8 valence electrons, its stable electron configuration. And as a result, the atom gets lower in energy. It becomes more stable and its energy drops. So what we're going to be talking about today is chemical energy. And chemical energy is the particular form of energy that's involved when a bond is formed and when a bond is broken. So we're going to talk about how chemical energy changes during bond forming and bond breaking. So here's a really good diagram of exactly what happens over the course of a chemical reaction. And we're going to cover those soon, but we can talk about it today. So you're going to start out with some initial, what are called reactants, starting molecules. But in order for them to react with each other, all those bonds between them, all the bonds that hold the molecules together, they've got to be broken. So you can get to this point where you have free atoms out there that can be rearranged and ultimately form the products of the reaction. So the thing is, to start any chemical reaction, you have to break those bonds in your starting or your reactant molecules. So if you imagine if you were holding a pencil in your hand, if you were going to break it in half, you'd have to put energy in to break it. Like you would have to put your own energy in, you'd have to push on that pencil to the point that it breaks. So breaking a bond is similar to breaking a pencil. Breaking bonds takes in energy. And in chemistry, we call that process, any process that takes in energy, endothermic. The N, like energy's entering to break the bonds. Now, at that point, the atoms are free-floating momentarily, if you want to think of it that way. They quickly rearrange themselves and form new bonds. So they go from an unbonded state where they are less stable to a bonded state where they are more stable. In the process of going from the unbonded state to the bonded state, the atoms become more stable. Because they're becoming more stable, they become lower in energy. So whenever chemical bonds are formed, there's always some release of energy because the atoms now are more stable in the bonded state than they were before they formed those bonds. Okay, so I keep hitting the wrong button. Sorry, guys. When you break a chemical bond, I want you to think about breaking your pencil. You have to put your own energy in. You have to push on that pencil to break it. So energy is absorbed whenever a bond is broken. And any process that takes in energy, it's absorbed or the energy enters the substance or the process to make it occur. We call those processes forming a chemical bond. You're going from unstable individual atoms to a more stable bonded state. You're going from a state of higher energy to lower energy. So when bonds form, energy is released as the atoms become more stable via the bonds they've made. The energy that is released is actually stored in the bonds themselves, and we'll talk about that more. But for now we'll say that some of that energy at least is stored in those bonds. The point is energy is being released, and any process that releases energy overall is called exothermic. So the EX and X, a little memory trick, makes me think exit. Energy is exiting as the bonds are formed and the atoms that compose them become more stable. So a quick memory trick to help you remember the energy changes that occur when bonds are formed versus broken. It's gross, but it works. It's BARF, B-A-R-F. So when bonds are broken, energy is absorbed. And when a new bond is formed, energy is released. So BARF, B-A-R-F. All right, so let's practice, and then you can get working on your quiz review to get ready for Monday's quiz. Here we have, this is basically a chemical equation. And what we can see is we start with 2 individual bromine atoms. And by the time this whole thing's done, now we have Br2, which implies that a bond formed. We had 2 individual bromines that now connected together or bonded together to make a molecule of Br2. So this represents bond formation, not bond breaking. And when you form a bond, the atoms become more stable. They release energy. They become lower in energy. Or you can think of it that way, or you can remember BARF. Breaking bonds absorbs energy, but energy is released when bonds formed. So we formed a bond. Those bromines are now more stable than they were in the unbonded state. Energy came out. It was released. Out of endo and exo, think exit. Any process that releases energy is exothermic overall. Endothermic means energy was entered or was absorbed overall. Okay, please use the rest of this time productively. Please work on your quiz review. You can, if there's some questions, feel free to, talk to Mrs. Newber about it. Or if you want to save them for me, I will give about 15 minutes before your quiz on Monday to answer any last minute questions and just let you look stuff over one last time. I will teach you on Monday before your quiz. So again, I can't stress it enough. Use this time productively. All right, good luck, guys. Happy Halloween. I look forward to seeing you next week. Oh, one more thing. I almost forgot. Don't forget, the complete answer key to that quiz review is posted on Google Classroom. Use the answer key. Open it up and look at it. Check yourself for anything that doesn't auto-grade. All right, I'm really done now. Happy Halloween. See you next week.